Okay. All right. Now, let's move on. That was project part 3. And my thing is going to be all screwed up on me, isn't it? So now we're going to talk about the range rule of thumb. And the range rule of thumb is when you have, oh, come on, don't do this. Options, output 2, output 2. Try that. This could be trouble. There we go. Okay. Range rule of thumb. How about Alyssa? Go ahead and read. Good. So this was your quiz. Quiz problem 1. So you need to figure out how to find the things that are important. What do you need? You need to find your mean. You also have your sample size, and you have your standard deviation. When it says a mean of, that's your mean. When it says a standard deviation of, that's your standard deviation. When it says a sample of, that is not your mean. When it says a sample of, that's your n. That's your sample size. A sample of 50 students means you sampled 50 students, and that's how many you sampled. So get used to these clues, these kind of clues it gives you, verbal clues it gives you now, so you can identify stuff later, because it's going to get, this is fairly simple still, but it's going to get more complicated. So you kind of want to get in that habit of being able to identify things quickly. So sample of 20 math books. 20 is my what? Sample size. That's my n. Has a mean of 678.4. So this is my x bar, my sample mean. And then what's 41.1 pages? What's that?
Standard deviation.
That's my standard deviation, my s. Okay. Everybody okay with that part? So, range rule of thumb. Anytime you see the words range rule of thumb, that's your clue. That's going to be take your mean, and you go 2 standard deviations this way to find your lowest usual value, and you go 2 standard deviations this way to find your highest usual value. Range rule of thumb says that typically most of your data lies within 2 standard deviations. So you go 2 this way from your mean and 2 this way from your mean to find your usual lowest and usual highest, and these will be your, this is your usual range in here. So that's the reasoning behind it. So what we'll do is, you can do it either of 2 ways. The first way you can do is, you can find 2 standard deviations. So 2 SDs is going to be 2 times 41.1, which is 82.2. So I can either do the min would be 678.4 minus 82.2. So that would be, would you guys get 5? Help me out.
96.2.
96.2, great. And then your max would be 678.4 plus 82.2. Whoops. Which is?
760.6.
760.6. Great. Perfect. Or you could have done the visual way instead. And then the whole little, this guy, and here in the middle is my mean, which is 678.4. And I'm going to jump 2 this way. So I'm going to add 41.1, add 41.1. And that will get me to 760.6, however you do that. And then you can go the other way, subtract 41.1, and subtract 41.1. And that would get you to the 596.2. So either way you do it, these are my min and max usual values. Would a book with 620 pages be unusual?
No.
No, because it's in the range. Coefficient of variation. No, go ahead and read.
The coefficient of variation, or CV, for a set of non-negative sample or population data expressed as a percent, describes the standard deviation relative to the mean.
Yes. So remember, this is the whole idea of what percent of the whole is your standard deviation. So you take your standard deviation, divide by the whole. In this case, the mean is kind of our best representation of the whole, of what a whole amount would be. And you change it to a percent, right? So do you guys need 15 seconds to do this, or have you all done it? Okay, done? Great. So again, sample of, so this is my, what's this? What's 36 stand for, guys? Sample size, that's my N. What's 65 inches? What's that? It's my mean, my what? My X bar. And then what's 16? That's my variance, which I don't really need necessarily. That's my S squared. And then I have, what's my 4 inches? That's my S, my standard deviation. So the one that we usually use is the standard deviation. That's the one that's going to be in the same, see how those are both in inches? This is this weird inches squared thing. Do you guys see that? The variance? The variance is, that's the one we don't use as often. That's the one that's kind of more complicated. It has the S squared in it. The one we generally use is, for the most part, is going to be standard deviation. And that's the one that has the same units, our S. So which one do I need for this one? Yep, S. So it's going to be S over X bar times 100%. So it's going to be 4 over 65 times 100%. Prob, what'd you get? Prob, what'd you get? 6.2%. Forget the percent. Okay? Good. Chevy Chevs. You guys remember Chevy Chevs? He was the one who said he gives the minimum amount that is within a certain number of standard deviations. The beauty of Chevy Chevs is it applies to all distributions. It does not have to be normal. Remember, it's a minimum. That's the bare minimum. Usually it's more. So, so within 2 standard deviations, if we're talking 2 standard deviations, then 1 minus 1 over 2 squared, which is 1 minus 1/4, 3/4 of the data, or 75% of the data, would be within 2 standard deviations, at least. Usually more. And then within 3 standard deviations, if I go 3 standard deviations, then at least 88.89, so roughly 89% will be within 3 standard deviations. So that's 1 minus 1 over 3 squared, 1 over 1/9. Sorry, 1 minus 1/9, which is 8/9. So that's Chevy Chevs. How do you know? It'll say Chevy Chevs. Please do this. This is a typo. See where it says 75% of light bulbs? Change that to at least 75% of light bulbs, because that's an error as it is. It's not 75%, it's at least 75%. That's a big difference, right? Because if you have to be at least this height to ride this ride, it's a lot different than you have to be this height to ride this ride. All right. So with this one, what percentage of light bulbs lie within 3 standard deviations of the mean? 89%, roughly 89, if we round to the nearest percent, 89%. And then at least 75% lie within what and what? 2 standard deviations. So within 2 standard deviations of 600, this is my mean. You guys see that one? That's my x bar. This is my standard deviation, S. So it would be between what and what, you guys? 300 and 900. Because 2 standard deviations would be 2 times 150, 300. So then we'll have, for this one, we'll have 600 minus 300. And for this one, we'll have 600 plus 300. The empirical rule. Megan, go ahead.
For data sets having a distribution that is normal or approximately bell-shaped, mean better
Yeah.
About 68% of all values follow the inverse standard deviation of the mean. About 95% of all values follow within 2 standard deviations of the mean. About 99.7% of all values follow within 3 standard deviations of the mean.
Great, thank you. Right, so if we know it's normal, that's the big if. If it's normally distributed, then we can do better than Chebyshev. Chebyshev says that 2 standard deviations will be between 75% and 100%, somewhere in that range. If it's normal, we can say, oh, it's right around 95%. That's a lot more accurate than between 75 and 100. Right? And Chebyshev says that with 3 standard deviations, it's between 89% and 100%. This one's more accurate. It says right around 99.7%. Really a lot. 99, probably between 99 and a half, 99 to 100, kind of. It's right in that range. Okay, so that makes that a lot clearer. So let's go ahead and take a look. Here's it as a picture if you want to take a look at that. And I will give you guys 30 seconds now to finish this one, this next lab problem up if you haven't done it yet, lab problem 4. Okay, so let's take a look at this one. I think yours was what percent should be between, so here's one way of doing this one. Here's my mean. What was my mean? 165. And I'm going to jump standard deviations this way. Plus 6, plus 6, plus 6. So I'll get to 171, 177, 183. And I'll go backwards. Minus 6, minus 6, minus 6. And that'll get to me to 159, 153, sorry, and 147. So yours was what percent would be between 153, or was it 159 and 153? 159 and 171. So you should look on there and say, oh, here's 159, here's 171. How many standard deviations away from the mean is that? Oh, it's 1 in either direction. So that should be what? 68%. And then your other question was, what percent should be between 153 and 177. 153 and 177. So then you look up here and you'll say, oh, that's 2 this way and 2 that way, so that should be what percent? 95%. Okay, great. Here is a problem that you guys will have in the homework. What was this? 65, 171, 177, 159, 153, 147. Okay, so here's the thing. What if I say within 1 standard deviation? If I say from 159 to 171, you guys know that's 68%, yes? But what if I say, what's the amount more than 171? That's a little bit different. You guys know this part here is 68%. Everybody agree with that part? If the inside is 68%, the inside is 68%, what percent is on the outside? 32%, because it better add up to 100%. So we know that this section here, I'll stick these out to make it even cleaner for me. We know that this section plus this section had better add up to 32%. We also know this is symmetric, right? The left side is the same as the right side. So whatever is on the left should be the same amount on the right, which means that how much should be on each side? 16%, half on each side. It's symmetric. So this should be, this part here should be 32% divided by 2, 16% on each side. Everybody all right with that part? Good, you can find it on your homework when you have it. Okay, if not, come back to this video. Now we're going to look at measures of relative standing. Basics of z-scores, percentiles, quartiles, and box plots, which we covered z-scores a little bit last class. 10 seconds with your neighbors. Figure out what those symbols are for population mean, population standard deviation, sample mean, and sample standard deviation. Population mean, what's the symbol? Mu. Mu. Like the Pokemon. Mu. Population standard deviation, what's the symbol? Sigma. Circle with the tail. Are these statistics or parameters? Parameters. They're for a population, so they are parameters. What's the sample mean symbol? X bar. Great. Sample standard deviation. S. Terrific. Are those statistics or parameters? Statistics, because they're for a sample. Everybody on board with that? Yeah. So if we're talking about a sample, we take a sample of a bunch of weights of cats. How much all these cats weigh? Their average weight is going to be a statistic or a parameter? A statistic. If I compare them to what all cats weigh, the average of all cats would be a parameter. That would be the population mean. You, like a cat. Oh, you. Right, perfect. values. So we needed those to kind of refresh your mind before we get to z values. So again, remember a z-score. How do we find a z-score? First you have your mean. Figure out how far from the mean you are. You take that difference. If it's above the mean, it should be positive. If it's below the mean, it should be negative. You take that difference and then you divide by a standard deviation to figure out what that is in terms of how many standard deviations that is. Because a z-score represents the number of standard deviations a value is above or below the mean. You guys read these two lines with me, just these first two. Ready? 1, 2, 3. Good. You need to know that for the next exam. You need to know that, really, for the rest of the semester. It's going to come up over and over again. Chapter 3, chapter 6, 7, 8, and 9. It's all over the place. You need to understand what a z-score is. In other words, how far you are from the mean. How do you find it? You take the value, your value that you care about, subtract the mean, and divide by standard deviation. For a sample, this is it for a population. For a sample, it would be x minus x bar over s. That's when you're going to be using the most. I think a lot of people have a lot of trouble visualizing it because they have a hard time wrapping their head around a standard deviation. So sometimes it's helpful to think of standard deviations as kind of like car lengths because we all are familiar with that. Like we all can kind of, you've all heard like the thing of like, you're supposed to stay 3 car lengths behind the car in front of you. And you kind of, when you're younger, at least you kind of time out how many car lengths you are from the car in front of you. Right, Clayton? So when you do that, you kind of get used to estimating, oh, I'm like 1.5 car lengths behind the car in front of me. Oh, I'm about 2. You know, and I'm a little more than 2, a little less than 2, right? So if you think about them in terms of car lengths, it might help you wrap your head around it a little bit better. So for here, here's where I am. There's my mean. I'm like 1.72 car lengths, roughly 1.72 standard deviations away from the mean. So my z-score would be 1.72. So it kind of might help you sort of get a better mental picture of it because people have trouble relating to it very well. And you know, it's also kind of nice because like if you remember, every problem has a different standard deviation or different car length. Some are really big, some are really small, some are kind of average. It kind of depends upon the problem, where your data is really spread out or really like all squished together. So do you guys need a minute to do quiz problem number 1? Do you guys do it already? Clayton, go ahead and read it for us. Clayton, go ahead and read it for us.
What score is relatively better? A score of 81 on a psych test or 42 on an econ test? Scores on a psych test ranking of 89 with a standard deviation of 6, and scores on the econ test having a 50 with a standard deviation of 8. And find the z-scores.
Right, so find the z-scores for these two things. So figure out what you are interested in, what your score is, and then figure out what the mean is and the standard deviation is, and then you can use that to compute the z-score. There's one for econ, there's one for psychology. Do you guys need just a minute to do these? Has everybody done them, or does everyone need just a minute to do these? Done? Who has these done already? Okay, everybody's got them done. I'll give you guys 30 seconds to do them if you haven't. Go now, quickly. Okay, so let's look at the psychology stuff in purple. So my psychology score is 61. That's my X. That's what I care about. What's my mean for the psychology test? So it says psychology test has a mean of 89. That's my X bar. Different than X, X bar. With a standard deviation of 6. So 6 would be my S. So here my Z-score for psychology is going to be my value, 81, minus the mean, 89, divided by standard deviation, 6. Negative 8 over 6, negative 1.33. Usually we go to 2 decimal places for Z-scores. And then we can take a look at econ. So here, 42, that's my X, that's the score I care about. It has a mean of 50, that's my X bar, and a standard deviation of 8, that's my S. So my Z-score for econ would be 42 minus 50 over 8, negative 1. Which one would I rather have? Which one's better? Econ, because you're only 1 standard deviation below the mean instead of 1.3, instead of more. Everybody okay with this part? Does that make sense to folks? You'd like to be above the mean, ideally, not below the mean. But either way, you'd like to be less below the mean than more below the mean. This is negative 1 is better than being negative 1.33. Find the percentile. The percentile is all about how many people are below you. What percent of people are below you? So you count how many people are below you, and you find what fraction of the whole they represent, and then change that to a kind of a percentage. Multiply by 100%. The book does a little bit differently. That's totally fine too. What they do is they add a half and then they round to the nearest whole number, which works out the same. What we do is we round up. But I'll show you what I mean. So, do you guys need? Who's done with this part? Okay, let's go ahead and go through it. Age 36. So which ones were before less than 36? These guys. 36 is not below itself. You can't count that one. How many are there? 8. 8 out of how many? 36. So 8 out of 36 is how much? 22? 0.22, and then write that, multiply by 100%. So you'll get 22%. So it's the 22nd percentile. Okay? Make sense? Yes.
It's actually 0.22222.
Yep.
So what percent would you use?
I would round it. So you can either have no decimal places, or you could have one. If you did 22.2 percentile, that'd be okay too.
Okay.
I would say either none or one. Either one's fine. This is the thing we touched on last class, where we looked at the kind of the opposite, right? So what we did, we said that percentile is equal to the number of things you beat divided by n times 100%. And how do you, if you want to solve for L, what do? You multiply this by n divided by 100, n over 100. That way, these guys cancel out, those guys cancel out, and you're left with L is equal to n times k over 100. That's where this guy comes from. Where L is the number of people that you beat, number of people lower than you. So here, we'll take a look at one of those examples which we did last class, but it was kind of at the end, so you guys may have forgotten. Here we have 20-point test to 10 students. That's my n. You want the 25th percentile. So my L is going to equal my percentile divided by 100 times n. So that's going to be, my percentile is going to be 25 out of 100 times 10, so 2.5. That means I beat 2.5 people. Who beats 2.5 people? There's 2 people, and then there's a half. This guy beats 2.5. He's the third guy. The third guy beats 2 people up to 2.999 people. Does that sort of make sense?
Yes.
He doesn't beat 1.9 people because the guy in the 2 spot beats 1.9 people. The third spot, he beats 2 people up to 2.999 people. So that's, remember, this is the position. This is how many people you beat. So the person who beats 2.5 people is the third guy. So I want you guys, bust out your notes from last class, 3.3 notes, and do problem number 4, which is second page. Second page, 3.3 notes. Second page, kind of halfway down. Problem number, problem 4. And they need them? Yes? You want me to? Yes. Nope, that's 3.2. 3.3.